This salt can be further treated with cuprous halide. So therefore you get aryl halide. Heating in aqueous sodium hydroxide solution at a temperature of 623 Kelvin and a pressure of 300 atmosphere. So ethanol of 1% is added to retard the oxidation of phosgene into harmless ethyl carbonate. The instability of phenyl cation. Phenyl cation is not resonance stabilized, so it is unstable molecule. Hello dear students, I am Roja, your chemistry lecturer from Vidhyaashram PU College, the Temple of Excellence, Mysuru. So today we are going to continue the chapter Haloalkanes and Haloarenes. So in the previous session we have studied about SN1 mechanism, that is substitution nucleophilic unimolecular, and also bimolecular, that is SN2 mechanism, then stereochemical aspects of nucleophilic substitution reactions, then SN1 mechanism in optically active alkyl halides, then SN2 mechanism in optically active alkyl halides, then order of reactivity of various alkyl halides, that is in SN1 and SN2 reactions. So in this session we are going to study about haloarenes, then electrophilic substitution reactions, then reaction with metals, and also about polyhalogen compounds. So like how are we able to prepare haloarenes using different compounds? Let us see one by one. So first step is by electrophilic substitution reaction. So aryl chlorides and bromides can be easily prepared by electrophilic substitution of arenes with chlorine and also can be bromine respectively in the presence of Lewis acid catalyst like iron or iron 3 chloride. So here is a reaction equation. So this is a methyl benzene wherein it can be called as toluene also. So X2 represents halogen, whether it is a chlorine or bromine. So in the presence of Lewis acid catalyst, that is iron, so we can obtain orthohalotoluene and parahalotoluene. So the ortho and para isomers can be easily separated due to large difference in their melting points. So ortho and para gives the large difference in the boiling points and the melting points of the compound. So therefore it can be separated. Next is Sand-Meyer's reaction. So when a primary aromatic amine dissolved or suspended in cold aqueous mineral acid, it is treated with sodium nitrite, a diazonium salt is formed. So mixing the solution of freshly prepared diazonium salt with cuprous chloride or cuprous bromide results in the replacement of the diazonium group by Cl or Br. So here is the reaction wherein benzene amine is being carried out with the reaction, that is sodium nitrite along with the presence of hydrogen halide. So you get benzene diazonium halide. This salt can be further treated with cuprous halide. So therefore you get aryl halide. So the equation X represents halogens. It can be a chlorine and bromine. So next step is replacement of diazonium group by iodine does not require the presence of cuprous halide, has happened in the case of chlorine or bromine, and is done simply by shaking the diazonium salt with potassium iodide. So to form iodine molecule to the benzene, it is not necessary to react with in the presence of cuprous halide. So therefore it can react with potassium iodide to give the diazonium salt with iodine. Next is reactions of haloarenes. So how are they going to react with other molecules or the substances? So in that first one is nucleophilic substitution reaction. So aryl halides are extremely less reactive towards nucleophilic substitution reaction and due to the following reasons. So the first reason is about resonance effect. So resonance effect, we have been studying it from the previous chapters also. So in haloarenes, CCl bond acquires a partial double bond character due to resonance effect. As a result, the bond cleavage in haloarene is difficult than haloalkane and therefore they are less reactive towards nucleophilic substitution reaction. So here chlorine is going to donate electron towards the benzene and therefore the double bond is going to shift to the adjacent atom and therefore the electrons are going to shift one after the other and one after the other, leaving the chlorine with plus charge, and therefore because of this resonance effect it is going to have less reactive towards nucleophilic substitution reaction. Next is difference in hybridization of carbon atom in CX bond. So in haloarenes, that is CX bond is less polar as carbon in sp2 hybridization. So however, in haloalkanes, CX bond is more polar as C in sp3 hybridization. So as a result, CX bond is shorter in haloarenes and it is very difficult to break. So therefore, it shows that carbon in sp2 hybridization, it is going to be less polar. Carbon in sp3 hybridization will be highly polar. So therefore, it becomes very difficult to break the bond between carbon and halogen. Next is instability of phenyl cation. Phenyl cation is not resonance stabilized, so it is unstable molecule. And then high electron density on benzene. So that is also one of the factor wherein because of the possible repulsion, it is likely less for the electron-rich nucleophile to approach electron-rich arenes. So next is nucleophilic substitution reaction. So here the first one that we can study is about replacement by hydroxyl group. So hydroxyl group is nothing but OH group. So in chlorobenzene, it can be converted into phenol by heating in aqueous sodium hydroxide solution at a temperature of 623 Kelvin and a pressure of 300 atmosphere. So in this condition, chlorobenzene can be reacting with sodium hydroxide and therefore this chlorine molecule is being replaced by the hydroxyl group. So making it phenol. Next is in chloronitrobenzene. So the presence of an electron withdrawing group, that is NO2, at ortho and para positions increases the reactivity of haloarenes towards the nucleophilic reaction. So therefore, no effect on reactivity of haloarenes is observed by the presence of electron withdrawing group at meta position. So it is only about ortho and para positions wherein we can see the electrophilic substitution reaction. So here are three different reactions wherein first reaction says that we know it is NO2, the electron withdrawing group. So at the temperature is about 443 Kelvin. So this chlorine atom is being replaced by OH, making it wherein NO2 groups are in ortho and para position, not in the meta position. So this will make the reactivity more towards the nucleophilic substitution reaction because of the stabilization. And in the second reaction, the same molecule but at a different temperature, but then electron withdrawing group will be at the ortho and para position. There is no change in that. So it will also make the reactivity more towards the nucleophilic substitution reaction. But then there is one more reaction whereas electron withdrawing group is in ortho meta para position. So therefore, at condition is at warm temperature, therefore the reactivity of haloarenes will be less because of the position of electron withdrawing group. So next is electrophilic substitution reaction. So here halo group is itself is a electron withdrawing group, yet ortho and para directing in electrophile substitution due to resonance effect. So here halogen is being a electron withdrawing group, therefore it is going to donate the electron towards the adjacent bond and the bond adjacent to S is being shifted to the adjacent atom, and this halogen atom will possess positive charge because it has given the electron towards the benzene ring, and one which has donated the bond broken down and donated the bond to the adjacent atom has possessed negative charge. So this negative charge is in ortho position. So this electron withdrawing group of halogens will be in ortho position or in the para position, or again it can be in a ortho position. So this is due to the resonance effect. Due to -I effect of halo group, ring gets a little deactivated. As a result, electrophilic substitution in haloarenes is slow and requires more drastic conditions. So that is because of the -I effect. Next is different types of electrophilic substitution reaction. So first one is halogenation. So when chlorobenzene is heated with chlorine in the presence of anhydrous aluminum chloride, a mixture of ortho and para dichlorobenzene is obtained. So a mixture of ortho and para, so in that position we can find halogen atoms. So chlorobenzene along with the chlorine in the presence of anhydrous ferric chloride, or it can be aluminum chloride also. So the chlorine atoms will possess a place where ortho and meta position. So this 1,4 dichlorobenzene is of major product and this 1,2 dichlorobenzene is of minor product. The next one is nitration. So when chlorobenzene is heated with a mixture of concentrated HNO3 and concentrated H2SO4, a mixture of ortho and para chloro nitrobenzene is formed. So that is why it is named as nitration process. So chlorobenzene along with a mixture of both concentrated nitric acid and concentrated sulfuric acid would give ortho and para chloronitrobenzene. So here chlorine and nitro is in 1,2 position. So it is 1-chloro 2-nitrobenzene. It's of a minor product. Next 1-chloro 4-nitrobenzene. It is of a major product. So next is sulfonation. When chlorobenzene is heated with concentrated sulfuric acid, again a mixture of ortho para chlorobenzene, sulfonic acid is formed. So it is known as sulfonation. So chlorobenzene along with the presence of concentrated sulfuric acid, this consists of a sulfonic group. So this sulfonic group is in the position of 2, therefore 2-chlorobenzene sulfonic acid, it's a minor product. Again, it's 4-chlorobenzene sulfonic acid is in a 4th position, so therefore it is a major product. Next is electrophilic substitution reaction, wherein we can understand about Friedel-Crafts reaction. So Friedel-Crafts alkylation and acylation also there. So let us study first about alkylation. So when chlorobenzene is heated with methyl chloride in the presence of anhydrous aluminium chloride catalyst, a mixture of ortho and para chlorotoluene is formed. So here is a chlorobenzene and methyl chloride in the presence of aluminium chloride. So this chlorine is going to take a position of ortho. So it is 1-chloro 2-methyl benzene, and again a mixture 1-chloro 4-methyl benzene. Next, acylation, that is Friedel-Crafts acylation. So when chlorobenzene is heated with acetyl chloride in the presence of anhydrous aluminium chloride catalyst, same a mixture of ortho and para chloroacetophenone is formed. So here chlorobenzene along with that acetyl chloride, this whole group is going to take a position of ortho and para to give a mixture of both ortho and para chloroacetophenone. So here is a product mixture, that is 2-chloroacetophenone and 4-chloroacetophenone. Next is how are these haloarenes going to react with metals? In that first type is Wood's fatigue reaction. So when a mixture of alkyl halide and aryl halide is heated with sodium in dry ether medium, alkyl benzene or it can be called as alkyl arene is formed. So here is a general reaction wherein aryl halide along with the sodium and then alkyl halide in the presence of dry ether medium. So alkyl group is going to replace the halogen group to give alkyl benzene along with that sodium halide. So the same reaction with the example, that is bromine, bromobenzene plus sodium, then methyl bromide. Therefore, in the presence of dry ether, it is going to give toluene plus sodium bromide. Next is only about fatigue reaction. So when aryl halides are heated with sodium in dry ether, two aryl groups join together forming biphenyl. So two molecules of aryl halide is going to react with sodium in the presence of dry ether medium. So there creates a bond between two phenyl groups, making it biphenyl plus 2 atoms of sodium halide. So next is polyhalogen compounds. So what are those polyhalogen compounds are? The name itself says that more number of halogen atoms in a compound. So in that first one is dichloromethane having a formula CH2Cl2. So what are the uses of dichloromethane? Let us see into it. So it is used as a solvent in drug industry, and it is used as a paint remover and propellant in aerosols. Then it is used as a cleaning agent for metals. So second is the environmental impact about this dichloromethane is its direct contact to our skin develops redness and burning sensation. So it is very harmful, and it is harmful to our central nervous system as well. Then its high level in air causes nausea, numbness in fingers and toes. Next compound is trichloromethane CHCl3, which is also known as chloroform. So chloroform is a sweet smelling liquid. Boiling point is having about 334 Kelvin. It is also a non-inflammable, but its vapor causes unconsciousness. So we are much aware about it. Then when exposed to sunlight and air, it slowly decomposes into phosgene, which is having a formula COCl2. A poisonous gas it is, so it is therefore stored in closed dark colored bottle completely filled so that air is kept out. Then the formula and the reaction when it goes to react with the atmospheric oxygen is, so chloroform in the presence of oxygen, that too in the presence of sunlight, it is going to give phosgene, a poisonous gas, along with hydrochloric acid. Now it has got some applications also, let us see to it. So it is used as a solvent for fats, oils, varnishes, waxes, resins and rubbers, etc. For the preparation of chlorotone, that is a drug, and then chloropicrin, that is also a insecticide, and it is used as an anesthetic after being mixed with ether. Then it is used in the manufacture of freon. Freon is used in the refrigerator as refrigerant. Next, what is the environmental impact of chloroform? So on inhalation, it depresses the central nervous system and causes headache and dizziness. Then chronic exposure damages liver and kidneys. Then on exposure to sunlight and air, it slowly decomposes to give a poisonous gas, that is phosgene. So ethanol of 1% is added to retard the oxidation of phosgene into harmless ethyl carbonate. So next one is triiodomethane, having a formula CHI3. It is also called as iodoform. It's a yellow crystalline solid having pungent characteristic odor, and melting point is around 392 Kelvin, and it is steam volatile. So it is used as antiseptic for dressing wounds. Now, what are their uses are? It is used as an antiseptic for dressing of wound and in the manufacture of certain pharmaceuticals. Now, what are the environmental impact are? When it comes in contact with skin, iodine is liberated, which is responsible for antiseptic properties. And then it has an objectionable smell, so it is unbearable to smell. Next is tetrachloromethane, that is carbon tetrachloride, CCl4. So it is a liquid and having a boiling point 350 Kelvin. It is non-flammable, hence used as a solvents for fats, oils, waxes and resins, etc. So it is used as a fire extinguisher under same name, pyrene. So let us see what are their uses. It is used as fire extinguishers and it is used as a solvent and also for dry cleaning. So it is used in the medicine as helminthiside for elimination of hookworm. And then what are the environmental impacts are? So its vapors when breathed causes nausea, dizziness, vomiting and may cause damage nerve cells permanently. Then on exposure it causes cancer, irregular heartbeat and a person may go to coma. Then its vapor depletes ozone layer. So ozone hole permits the ultraviolet radiation to reach on earth and may cause skin cancer, eye disease and disorders which may adversely affect on our immune system. Next is of freons, which is also known as CFCs, which is used as a refrigerant. So freons are small organic molecules containing carbon, chlorine and fluorine. The most common freons are CF2Cl, that is freon 12, and CF3Cl, it is freon 11. So what are their uses are? So in air conditioning and domestic refrigerators for cooling purpose it is used, and it is used as propellants in aerosol and foams to spray out deodorants, cleaners and insecticides. Halothane, that is CF3CHBrCl, is used as inhalation anesthetic. And there are certain environmental impacts about this compound CFCs, that is most freon eventually makes its way into the atmosphere where it diffuses unchanged into the stratosphere. In stratosphere, a freon is able to initiate radical chain reaction. So we have known about radical chain reaction that can upset the natural ozone layer surrounding the earth. If ozone layer is depleted, then it allows ultraviolet rays to reach the earth. Next is PP-dichlorodiphenyl trichloroethane, which is having a name DDT. So it is used as an effective insecticide for mosquitoes, flies and crop pests, and it is used as an anti-malarial. So what are the environmental impact are? DDT is the first chlorinated organic insecticide. Its stability and fat solubility is great problem. Then it is prepared from chloral and chlorobenzene in the presence of concentrated sulfuric acid. So here is the structure of DDT, which is prepared from chloral and chlorobenzene in the presence of concentrated sulfuric acid. So that was about the chapter haloalkanes and haloarenes. I hope you have understood. So thank you.